If your quest for longevity feels overwhelming, here's some good news. It starts with one simple daily habit. MitoPure gummies from Timeline. They're the first ever longevity gummies that ignite mitophagy, your body's natural anti-aging pathway. MitoPure is a clinically validated solution backed by over 15 years of research. MitoPure gummies utilize a powerful compound that redefines what's possible for your longevity. MitoPure produces the first ever urolithin A gummies that support your cellular energy so you feel strong, clear, and vibrant. Boost your cellular energy and enhance muscle strength and endurance, all without changing your diet or exercise routine. As someone who loves to stay active, I've noticed a significant boost in my workouts since I started using it. I feel stronger and more energized, and my recovery time has improved dramatically. Better recovery starts at the cellular level. For more information and to order, just go to timeline.com/Hoffman. Use coupon code Hoffman at checkout for 20% off. That's timeline.com/Hoffman for 20% off MitoPure gummies with code Hoffman. Welcome to today's Intelligent Medicine Podcast. I'm your host, Dr. Ronald Hoffman. Today we're going to look at what is likely to become a case study in corruption in our medical research establishment, how big pharma can sometimes enable shoddy science. The book is entitled Doctored: Fraud, Arrogance, and Tragedy in the Quest to Cure Alzheimer's Disease. A laudable goal. Several new drugs have been introduced, but the research in this field has a checkered past. And today we're going to talk to an investigative journalist. Charles Piller is an investigative journalist for Science Magazine, and his work has appeared in the Los Angeles Times, the New York Times, Sacramento Bee, and more. He's also been honored with many national journalism awards. His other books, Gene Wars, Fail-Safe Society, and now Doctored. He's reported on the public health beat. He's talked about biological warfare, infectious disease outbreaks, and many other topics on the international scene. And so welcome, Charles. A pleasure having you here on Intelligent Medicine. Thanks very much for joining us.
Thank you very much for having me. I'm glad to be here.
So why was it that you focused? I mean, there are many potential areas of malfeasance, corruption, fraud in science. Why was it that you focused on this particular instance to provide, in effect, a cautionary tale about where science can sometimes go against the public interest?
Well, aside from the fact that the story came to me and kind of, in a sense, fell into my hands, so often the case with journalism, I was very interested in this for a couple reasons. One is that unlike many of the other killers of aging, heart disease, and all kinds of other medical problems that we all are aware of, Alzheimer's has been a terribly difficult problem to solve. And there's a couple reasons for it. One is just a pure demographic lag period. So not enough people were living to very old age until fairly recent decades to make a big population of people, critical mass, you might say, for engendering the degree of interest that's required for the medical research community to devote the kinds of resources that are needed to really drop into the problem and try to solve it. That's one reason. The other is...
Just recently there have been lurid headlines about a prediction that the incidence of Alzheimer's disease may double by mid-century, that, as baby boomers age and the subsequent generations age, that there's something happening here. What it is ain't exactly clear. And more people, perhaps not just due to increased longevity, but that this is becoming more prevalent, and it's a big concern. It's really going to drain our healthcare budget and sap our productivity.
Well, I think those are legitimate concerns. I would say that it is primarily a condition of aging, of course, and as people live longer lives, it becomes more prevalent. So that's one of the issues. The other is that until about the early 1980s, not very much strong attention was placed on how to get at this problem disease and how to really invigorate the research environment to solve it. And even though there had been ongoing studies prior to that, things began to change in the early 90s with an idea associated with particular proteins in the brain that have to do with the idea that they would cause Alzheimer's disease. And this was studied very carefully, and a lot of science was developed around it. And it became gradually a kind of accepted wisdom that these amyloid proteins became the sort of bugaboo in the field. I mean, I don't mean to put it in a pejorative term. I think they became a very legitimate target for research. Mm-hmm. And a lot of research was done, and they became the accepted idea behind what is causing Alzheimer's disease. And I would just say that one of the things that I found in my research is that there was a really great acceptance based on a lot of logical thinking and a lot of important research that was done, but that when it became apparent that the certain kinds of proteins in the brain were thought to be the cause of Alzheimer's, they were studied very intensively, and yet it became very difficult to show that by removing them with various medicines, that you could actually get the result you're looking for. In other words, retrieving the cognition that was lost in patients who had this illness. And so what questions began to arise. In other words, was this the right path to be going down? And that became a very thorny problem in the scientific community, and in a sense, a kind of the starting point for the story that I tried to tell.
Yeah, my understanding as a physician is that there are these what are called fibrillary tangles in the brains of Alzheimer's patients. There's deposits of amyloid. And so amyloid becomes a potential target if we could just prevent or eliminate the amyloid, clean it out, in effect, rotor-rooter it, that thereby we might restore cognitive function. And it's been there's sort of been like an ups and downs in terms of research on that. It was actually thought that this was a promising avenue, and then it appeared that it kind of hit a dead end, and they said, this isn't really panning out. And now all of a sudden, the idea has been revived with the advent of new and frankly rather pricey and lucrative drugs that come with side effects and have some benefits, but rather equivocal benefits. Am I summarizing correctly?
Yeah, I think so. I would take it back just one more step. So sure. In the early 1990s, there was, a lot of development assuming that these amyloid proteins were the cause of Alzheimer's disease. And there was a lot of work that was done that was very interesting and pointed in that direction. And then as the years went on, drugs were developed to try to remove these from the brain in such a way as to, with the hope that they could improve cognitive performance, possibly even eventually be a cure for the disease. But there was a lot of disappointments, and they found that it was possible to remove some of these proteins from the brain and yet not achieve any benefit to the patient.
Right.
So there was a lot of concern and skepticism. And then I think the story gets a pretty interesting break point in 2006 with a quite interesting experiment that was conducted at the University of Minnesota. And this was done by a couple of Alzheimer's experts. And what they did is that they isolated a particular amyloid protein. This is a accumulation of a particular protein in your brain that was thought to be more specific than just removing these more general removal of the protein from the brain, but a kind of a very targeted approach. And they refined this in their laboratory experiments, and they injected it into rats, and they found that the rats displayed a kind of cognitive decline, if you might say. They weren't able to find a target that they were oriented towards that suggested a kind of impairment that was compared to Alzheimer's dementia.
Mm-hmm.
And so that was a pretty interesting demonstration. And it reinvigorated the research community with the thinking that we now perhaps are on the path of something that's very, very important, that maybe we were going about it a little bit wrong in the first place, but this made people feel that there was really strong hope for coming up with a way of fishing out the right kind of protein from your brain and therefore improving cognition, or at least arresting the decline of people who were experiencing the terrible effects of this disease.
And by the way, all the while, it appears that literally billions of dollars were expended in research along these lines. So we could talk about what are called sunk costs. In other words, there's sort of a momentum sometimes to research when you've expended a lot of capital trying to get to a goal. And I think that that has propelled this research forward, maybe while precluding other approaches that may be equally beneficial or potentially even superior.
I think I largely agree with you on that. I mean, what we had was a situation where these ideas about the removal of amyloid proteins from the brain became prevalent among scientists, and not for terrible reasons. I think there were thoughtful people who were identifying these as a proper target. But unfortunately, it came to the exclusion of other ideas about the disease. And consequently, other people found that their suggestions and solutions and research ideas for attacking the problem of Alzheimer's disease were not being funded, were being given short shrift by the gatekeepers of research funding and by the academic authorities because of the power and influence of those who supported this amyloid hypothesis. Now, at this point, I'm not saying that, the hypothesis was disproven. It was just a period of ferment in the research community. And then this experiment in 2006 really kind of influenced people to think we are really onto it now. Mm-hmm. We know that we need to be more precise in how we target these proteins to pull them out of the brain if we possibly can, to arrest and, hopefully someday even roll back some of the worst symptoms of the disease. So this was the path that was taken. And years went by, and there were a lot of new experiments with the removal of amyloid proteins from the brain. Time after time after time after time, they were not successful in improving cognition. Mm-hmm. And I should say very clearly,
the images improved, or the whatever chemical assay or molecular biology assay proved that the drugs were pulling it out. But then, where the rubber meets the road, the net effect on cognition, slowing the progression of cognitive decline and memory, didn't happen for patients.
Didn't happen. And that was, of course, terribly discouraging to all the people in this community, as well as, patients who are vesting their hopes on the possibility that some cure might come along in time for them to benefit from it. So it's a discouraging situation. Now, I'm going to go back in time a little bit to a couple of years ago when I first got involved in understanding this process 3 years ago. And at that time, I was talking with a scientist by the name of Matthew Schrag, and he was deeply involved in Alzheimer's research and other kinds of brain research. And one of the things that he was doing as part of his work was evaluating the veracity of scientific images to see if they had potentially been altered to prove a particular scientific point.
Wow.
And the fact is that,
by the way, I think there's a need for these types of people because, people who sort of ride shotgun on scientific research and maybe take a critical perspective on what seems to be settled science.
Yeah, I think that's a good way of putting it. I mean, we need people who are skeptical. Mm-hmm. And Schrag is a skeptical guy, and he was very determined to, this is sort of on his own time as a side project from his day job as a university professor and researcher. He was interested in seeing if he could get to the bottom of some questions about certain research that had arisen And one of the things he discovered, and this was actually after I started talking with him, and it was just in the very beginning of his journey along these lines, he discovered that a seminal study that identified this specific protein in the brain that they thought was critical to understanding Alzheimer's disease had been a study that looked like the images that were displaying the results of the study had been doctored. Mm-hmm. And when I say that, what I mean is that they have been improperly altered to prove a particular scientific point. Yeah. This was his perspective on it. He didn't make an allegation specifically about it, but it's like when you look at these images, you want to seek more information and validate your concerns if you can, or if your concerns to prove to be unfounded.
Something didn't add up, and he thought it was fishy that with his look, it takes someone with real deep knowledge of neuroscience and imaging, brain imaging, to have this understanding. I mean, I would read a paper like that and I'd go, hooray, moonshot. We have, we've got a breakthrough here. So these are the kind of people who I think we need to embed within our scientific endeavor to provide checks and balances.
Yeah, I think that's true. And I have a great admiration, not just for Dr. Schrag, but also there's a small army of people that regard themselves as forensic image sleuths in science now. And I think I need to put it in perspective, which is to say that I think the vast, vast majority of scientists are honest and deeply determined to solve problems in the legitimate way. You may agree or disagree with their findings because science is complicated. You may agree or disagree with their public statements about the importance of their findings. But what I look for is people who are honest and doing work in a legitimate fashion above reproach. And that is the vast majority of scientists in my experience. However, there are people who cut corners and sometimes people who engage in frank misconduct or even what you might call fraud in certain fields. Now,
let's just keep in mind that there are enormous pressures, research grants, there's tremendous competition. The underwriting from government, big pharma, and so on, tends to push people in a certain direction. And maybe, they're just sharpening up that image so that the contrasts were more discernible, a little white lie to move that project along. It's not like, outright chicanery.
Yeah, that's actually a good way of saying it, because I think those subtle changes, sharpening up an image in a certain way to make it more presentable and understandable, that happens pretty often. Mm-hmm. And what the problem is there can be a slippery slope to confirmation bias, you might say, sure, in your own thinking. And so when it takes the next step from saying, oh, well, I'm just going to sharpen this up a little to make the results that I actually got more discernible, to I know that I got the results that I wanted, or they're very close. I'm just going to change this image a little bit to reflect that thing that I feel so sure of more closely. Mm-hmm. And then ultimately you even get to the point where people fabricate images fully. So this is a terrible side of science that is really just a very small minority of scientists mm-hmm. who will go to that extent. I think scientists, whether their findings are useful or a red herring or going down the wrong path, most scientists are people of honorable intentions, and I'm not casting aspersions on them.
Clearly.
But we do have these other problems.
Okay, folks, at this point, let's pause and allow one of our sponsors an opportunity to share an important message with you. So here goes. Listen up.
Kids don't just bring home homework, they bring home germs. And those germs don't just stay with them, they spread to the whole household. That's why Clear Nasal Spray was created by a practicing physician to give parents and grandparents peace of mind. You may not think about it, but your nose is filtering out a semi-truck full of air every single day. Clear isn't just another spray. It creates an additional layer of protection in your nose that blocks bacteria and viruses before they can even take hold. Yes, even that virus. Supporting your body's defenses right where germs first try to enter. Clear is a hygiene product recommended for daily use, drug-free, Non-drowsy and safe for all ages. Just a quick spray in the morning and evening helps you cleanse your nose. Don't just hope for protection, create it. Get Clear Nasal Spray, your daily defense. Clear Nasal Spray is available at retailers nationwide and online. Check out xlear.com for our special offers. That's xlear.com.
Thanks for joining us. Thanks for supporting our sponsors. And now back to today's guest, Charles Piller. And by the way, there's been a wave of retractions of scientific papers, sometimes going back 5, 10, 15 years, when they actually look more carefully at the data sets, because sometimes, you don't publish all the minute permutations that got into the final statistical analysis. But actually, when people, my eyes would glaze over, but there's people who are able to do this. They crunch the data. They go, this doesn't make sense. And then questions arise. And then papers that actually have been the basis for major discoveries are suddenly pulled from the scientific literature. It's called a retraction, right?
Exactly right. In fact, there's an organization called Retraction Watch that has cataloged many, many thousands of these retractions and has, I think, contributed to an understanding that there should be more critical thinking about the possibility that some papers should be scrutinized more carefully. Now, let me make it clear that a lot of these retractions are, people make mistakes. Yep. Scientists are just people like anyone else. I'm not suggesting that everyone who has a paper retracted is guilty of some sin or misconduct, but some, unfortunately, are the product of deliberate manipulation and misconduct. And that's actually part of the focus of my book, is to understand where are the dividing lines and what is the meaningfulness of it in understanding where we are with this terrible disease.
Right. I recently talked about a case where a simple math error by a factor of 10, it was suggested that the amount of certain toxin or ingredient in a food posed a serious hazard. And then somebody quite simply pointed out that, oops, I think you made an error in your calculation and you magnified the hazard by tenfold. Oops.
Yeah, that's an
arithmetic
terrible
error.
Mistake. Yeah, it's a terrible, tragic mistake when that happens and influences people improperly in certain research directions. And look, we're human beings. People make mistakes. It's very unfortunate. It's even worse, though, when mistakes are deliberate. I guess they're not mistakes anymore. They're deliberate manipulations. And that is pretty much the focus of what I was trying to look at in my book, to understand the degree to which that kind of deliberate manipulation may have affected thinking in the field. And it goes back, in a way, to this, symbolically at least, to this experiment in 2006, which had a big effect on the field. It was one of the most cited experiments in the field, really, for many, many years, thousands of citations to it. And it was regarded by leaders in the field as an important step forward in our understanding of the disease. So naturally, when...
And excuse me, actually, scientists wear that as kind of a badge of honor, is, how frequently are you cited? If you're cited 5,000 times by other people in their papers, it really puts you in the firmament of the scientific establishment. And it's prestigious, and it translates to research grants and prestige.
Absolutely. It's critical to career development for scientists.
Yep.
And I might add that this particular study was published in one of the most prestigious scholarly journals in the world, Nature. And it was widely read, widely cited thousands of times by some of the most eminent scholars in the field. So it had vast influence. And the reason why this was so interesting and important is that it occurred at a time when there was some discouragement about this idea, the so-called amyloid hypothesis, of removing these particular proteins from the brain and being able to affect cognition in a positive way in Alzheimer's disease. So to me, this was fascinating. And the guy I mentioned earlier who I was talking to about this, Matthew Schrag, Vanderbilt University, he he was the one who sort of began to put the dots together on this problem, starting with this study. And so when I saw the enormous influence this study had, the enormous sway it had in thinking in the field, and realizing that based on his analysis, it might actually have distorted thinking in the field by presenting information that was falsely confirmed by improper images, manipulated images. I realized at once that this could be an important story to tell the world how corruption in a tiny little place, not vast corruption where thousands of studies are all suspect, but even one instrumental study can have a big influence if it's found to have been based on false pretenses.
Indeed. And it is kind of a case study. It sort of exemplifies where we do have concerns about scientific integrity that can lead to the approval of drugs that, A, are less efficacious than we'd like to see, and potentially where the risk-benefit equation does not favor their use. But ultimately what ended up happening is we do have Alzheimer's drugs now. So you talk about, in the book, about the advent of the Alzheimer's drugs. The first one was aducanumab. And talk about aducanumab, because it is based on the amyloid cleanup hypothesis that we now have some concerns about. But it generated a lot of controversy during its FDA approval. But there's a lot of pressure to get these drugs approved because we're talking desperate patients, desperate families. We're talking about the Alzheimer's Association, which is a so-called grassroots organization, patient-oriented patients' rights group, possibly in conjunction with a pharmaceutical firm that may underwrite their efforts to, shall we say, push for more accelerated approval. I think that's the term, of drugs that have the potential to help, not necessarily panaceas, but, gotta do something.
Yeah, it's an interesting case, in part because of the desperation of patients and physicians that you mentioned. People are understandably very anxious to get something that might have some benefit, even if it's not perfect. And in this case, this went up for FDA approval, and usually what happens is that there's an advisory committee that is composed of scientists and doctors who deeply understand the science behind these drugs and are able to give experts' opinions on how effective they might be and what the risks might be to patients and whether the risk-benefit ratio really balances out. And that's an important part of the approval deliberation process. These committees of scientists are not the decision makers. The agency is the decision maker, but they advise it, and their opinions are generally taken very seriously. In this case, the committee voted 10-1 to disapprove approval of this drug, 10-1, and the 1 was an abstention. So what you have is a pretty unanimous idea that the drugs were not safe enough, and that drug was not safe enough and not effective enough to warrant being licensed. Now, what the agency did is they went ahead and approved it anyway, which really was surprising.
They overrode the recommendations of their advisory committee, which is kind of unusual or perhaps unprecedented.
It's unusual. It's not unprecedented, but it does happen from time to time. But in this case, it was striking because there was this virtual unanimity on the part of the advisors that this would be a bad idea, but the agency went forward anyway. I think this speaks to a couple things. One is the desperation that people understandably feel to get something on the market that might be a possible benefit for this terrible disease. And the other is that the agency was under a lot of pressure from, their deliberations, their negotiations and discussions with drug makers to try to get things done. There's pressure on both sides. And so what ultimately happened is this approval that ended up being the drug was very expensive and never went into wide use because it wasn't very effective. And eventually,
it's an IV drug. It is a drug where you have to, from my understanding, get MRIs every few months. It can cause brain bleeding. It can cause hydrocephalus, which is like, I think, an accumulation of fluid in the brain. And so it's got some pretty serious downsides, and the upside was kind of marginal. It was not by no means a cure for Alzheimer's disease. And in terms of tangible benefits, it perhaps slowed the progression by a mere few months, I think.
Well, actually, I think there was a dispute about whether it had any benefit whatsoever.
Benefit at all. Okay.
Yes. I mean, I think some would argue that it had a very modest benefit.
Yeah.
But it was obviously, it wasn't a cure of any kind. It was, as you say, at best, a very slight slowing of the cognitive decline of patients. Now, that said, there are many people who even disagreed that that was really well supported by the data presented. So it was at best a very marginal drug. And I might add the story of that drug down the line, it was taken off the market.
Yeah.
But I should say that the FDA overruled the recommendations of their advisory committee, which was to not approve the drug. They went ahead and approved it. And several of the members immediately resigned in protest.
Mass resignations.
Yeah.
I remember that.
I mean, they felt that it was a shocking betrayal of the public health to approve this drug, which they regarded as, at best, a marginally effective at best, and also potentially hazardous. So this combination of factors was not great, but there have been a couple of drugs that have been approved since then.
I want to hold this up right there because we divide our podcast into two parts. We've laid the groundwork for a discussion in part two. I want to talk about what new Alzheimer's drugs have been approved and the case that can be made for them, but also the notion that our science, which we consider a pure endeavor, that sometimes can be tainted by doctoring. The book is entitled Doctored, which the subtitle is Fraud, Arrogance, and Tragedy in the Quest to Cure Alzheimer's. So when we return, our guest, the author, Charles Piller, is going to tell us a little bit more. And this reads really like a detective story. You've described it beautifully in the book, and how this whole process has unraveled. And I think it's a cautionary tale about medical research and how our drug development pathway in this country. I'm Dr. Ronald Hoffman, and this is the Intelligent Medicine Podcast.